here we go. And once again, for the recording, I will read this. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. That's right. Okay. So today we're going to be covering section 5.5, but before we do that, we're going to look at some questions from 5.4. I was emailed some questions last night, so I'm going to start with those, and then I'll open it up for other questions. So first of all, we're going to go to WebAssign, and we're going to look at problem number 18. Again, your particular problem number 18 might be different numbers from this, but this is from the student who requested it. It says evaluate the expression 1/3 b squared minus 1/9 b. Part A for b equals 9. So we're going to take 9 and substitute that in the place of b. So we're going to get 1/3 times 9 squared minus 1/9 times 9. Okay? Now, order of operations, we do exponents before regular multiplication. So the first expression, 1/3 9 squared, would become 1/3 times 81, or 81 over 1, and then minus 1/9 times 9, or 9 over 1. Well, 81 over 3 reduces down to, I believe that's 27. And 9 over 9 reduces down, so you've got 27 minus 1, which is 26. So be careful here. This does not turn into a 0. That turns into a 1. So then we get 26. All right? Let's take a look at the second part where it says, so this was part A. Part B, B is equal to -9. So now we've got 1/3 times -9 squared minus 1/9 times -9.
I can't see where you're writing that.
Because I didn't switch it back. My bad. I'm glad somebody finally spoke up. Yeah. If you're not seeing what I'm talking about, it means I forgot to click on things. Sorry about that. Let's go back. Okay. So part A, B equals 9. We were supposed to have this expression. Okay. So we're going to put 9. You know what? I'm just going to start over. All right. You can see this, correct?
Yes, thank you.
Okay. You're welcome. I'm glad you said something. So for part A, B equals 9. So we're going to put 9 in the place of B. So we're going to get 1/3 times 9 squared minus 1/9 times 9, which is 1/3 times 81 minus 1/9 times 9. All right. 81 over 3 reduces to 27. 9 over 9 reduces to 1. 27 minus 1 is 26. Are we okay with that?
Yes.
Okay, excellent. Part B, it's part B, B is equal to -9. So now we've got 1/3 times -9, the quantity squared, minus 1/9 times -9. So we get 1/3 times. Well, -9 squared, -9 times -9 is still positive 81. But here we've got, let's see, that's like subtract, let's see, -9 over 9, okay? So then subtracting a negative is like adding a positive. 27 plus 1 is 28. Are we okay with that?
Yes, thank you.
You're welcome, and thank you for letting me know. Make sure I'm showing the right stuff there. Okay, now
I think I got it to the point at 27. Oh, that was the second part of the problem. Okay, I see here.
you okay?
Yes.
You sure?
Could you explain the second part one more time?
So this thing here, the thing I just circled, this?
Yes.
Okay. So we've got this same original expression, okay? 1/3 b squared minus 1/9 b. Roger, you there?
Yes.
Okay, so 1/3 b squared minus 1/9 b. And b is supposed to be -9. So we've got 1/3 times -9 squared minus 1/9 times -9. Are you okay with that?
Yes.
So then we've got 1/3 times -9 times -9 is a positive 81. Okay. Minus, and then this would be -9 over 9. 81 over 3, so this is 81 divided by 3 is 27. Subtracting a negative is like adding a positive. Subtracting a negative is like adding a positive. You okay with that?
Yes.
And then 9 over 9 is 1, so 27 plus 1 is 28.
Okay. All right. Thank you.
You're welcome. Okay, let me see here. I need to go to this one and here. And let's see, this is a 5.4 here. And I know you can't see this. I'll get it up here on the screen and then I'll let you see what's going on here. All right, we're going to look at 13. Okay, so now, can you see WebAssign?
Yes.
Good. All right. Number 13, it says, find the degree of the polynomial. All right. So the degree of the polynomial is the same as the degree of the highest powered single term. -5x to the 9th, that first term, is of degree 9. The second term, 3x squared, is of degree 2. The third term, -3x, is of degree 1. But the highest powered term is the first term, -5x to the 9th. That term is of degree 9. So the degree of the entire polynomial is 9. You don't add up the different terms' degrees. You just take the highest powered term. Are you okay with that? I guess that's a yes. Let's take a look at number 15. Find the degree of the polynomial. The first term is 15a b to the 4th power. There is an implied 1 exponent on the a. So the 1 on the a plus the 4 on the b adds up to 5. So the first term, 15a b to the 4th power, excuse me, is a 5th degree polynomial. Okay? The second term is -13a squared b. There is an implied 1 on the b. So you've got a squared b to the 1 power, 2 plus 1 is 3. So the second term is of degree 3. Again, the first term is of degree 5. The second term is of degree 3. So the highest powered term is degree 5. So the degree of the entire polynomial is degree 5. I want to go back for a minute because I can see how people are perhaps getting confused. Can you see my cursor there moving on the screen?
Yes.
Yes.
Okay. Individual terms, you don't add the exponents. But within a single term, like this where you've got a b to the 4th, you do add the 1 on the a plus the 4 on the b, okay? So back here, I think the answer of 11 came from somebody adding the 9 and the 2, but you would just take the highest degree of any single term, okay? Finally, number 16, find the degree of the polynomial. So these are two separate terms. The first term is of degree 15. The second term is of degree 16. So the degree of the entire polynomial is 16. All righty. Okay, so now let's go back and open it up to any other questions that you may have. Those were the questions that came in. Anything else you want to look at in section 5.4 before we go on to 5.5?
Did you go over?
Yeah, I have a. Sorry, go ahead.
Oh, no, that's fine.
Oh, okay.
Go ahead.
Just really quick, I think on my last question, it's question 25,
Okay.
and it's got something about a box, and I got really lost in it.
Okay. 25.
I'm not sure how to.
Oh, yeah. Okay.
Yeah.
What is the polynomial that's given? Can you do that?
4x to the third
Okay.
minus 40x to the second plus 99x.
Plus how much?
99x.
99x. Okay. And then it says the sides are x inches long, is cut from each corner of a, what are the dimensions of the piece of paper?
9 inches times 11 inches. 9 by 11.
Okay. And find the volume of the box if, what size are the squares that are cut out?
2-inch squares are cut out.
2 inch. Do you mind if I go ahead and show yours so that they can see the things?
Yeah.
Okay.
Yeah,
All
of course. Go ahead.
Okay, hang on here. So, Sage, what section of Math 93 are you in? Do you know?
It says 5.4.
No. I mean,
08.
are you in 4765 or 4770 or 4780? Do you know which one you're in?
Let me.
You know what? I can find out. Let's see here.
Okay.
You are in 4765. Okay.
Yeah.
5 and say okay. And come on, folks. 5.4. And it's the last problem you said. Okay. All right. So there it is. All right. The only reason I ask is because sometimes people have done the problem, they've got the wrong answer, and I don't want, to show everybody they got the wrong answer if they care, blah, blah, but you haven't even done it yet, so there you go. Cool.
Yeah.
All right. So the polynomial 4x cubed minus 40x squared plus 24 plus 99x gives the volume in cubic inches of the resulting box, which is there on the right. Okay. Right over here is the box. Okay. Let's see. When a square of x sides x inch long is cut from each corner of a 9 by 11 box, find the volume if 2-inch squares are cut out. All right. So we've got this. Let's see, when a square. We've got this piece of cardboard that is 9 inches by 11 inches. Okay. I'm going to go to the work screen here, but I will give you the details. We've got this piece of cardboard that's 9 inches by 11 inches. Okay. We're going to cut a square from each corner of this piece of cardboard. So we're going to cut a square here and here and here and here. All right. Now, they don't specifically tell us the length of the side of those pieces we're going to cut out. They just say that it's X. So I'm going to switch to a different colored pen. This particular square
Wait,
right
isn't
here.
it 2-inch?
What?
Doesn't it say it's 2-inch? 2-inch
Oh,
squares?
oh, I do see that at the end there. Yes, thank you. I was not reading ahead. Find the volume blocks of 2-inch squares are cut out. Gotcha. Okay, my bad. So this piece is 2 inches by 2 inches. 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 Okay?
Mhm.
Thank you. You okay so far?
Yes.
Now, I'm looking at this because I think I'm making this problem a lot more difficult than it is. There's a problem that's in the book. It doesn't give the polynomial. All we need to do, this is ridiculous. I was making this big complicated thing. All we need to do is take the polynomial that's 4x cubed minus 40x squared plus 99x, gives the volume in cubic inches of the resulting box. When a square besides x inches long is cut from each corner of a 9 by 11 piece of cardboard, find the volume of the box if 2-inch squares are cut out. So basically, x equals 2.
Okay.
So all we have to do
Oh, okay. That's
that.
super easy then. I know how to do that.
but I think it's in the Math 141 book. There's a problem like this, but they don't give that original polynomial, and it's way more complicated than this problem is. My bad. Sorry about that. Okay, so this is 4.
No, that totally makes that makes a lot of sense. Like I know how to do it now. I just it was really complicated and I didn't.
Let's see, that's going to be what 38 plus 32 is 70 cubic inches. Yeah. Anyway, yeah. So really all they're doing is saying, oh, let x equal 2 and stick it in there. But I was making it way more complicated than it was supposed to be. You thought you were the only
Thank you.
Yeah. All right. Other questions from 5.4? Anybody?
I had one
Yes.
for problem. Well, it's not really a question. I just didn't exactly understand the process. There's problem 20.
Okay. Do you want me to pull yours up, or can we
Sure.
just look at a problem 20 in general?
Either is fine.
It says evaluate the polynomial. Let's see. You can't see it. Hang on. All right. What does your polynomial say? It says evaluate the polynomial 3ab squared, but I assume you have a different one?
I don't remember on mine here. I might have it on scratch paper. Let's see here. Let's see. Yeah, I don't remember exactly
Okay.
what mine was.
Tell you what, I'll
Just anyone.
I'll just use the one that's there.
Okay, that's all right. Thank you.
And then if you're still confused later on, contact me, okay?
Okay, thank you.
So what do you got here, there, and here, and here. So given 3a squared b, evaluate this polynomial when a is -2 and b is 3. So we're going to have 3 times a, which is now -2, times b, which is 3, squared. All right, so we've substituted the letters or the numbers in place of the letters. Order of operations, we're going to do the exponent first. What is 3 squared?
9.
9. So now multiplication from left to right. 3 times -2 is -6. -6 times 9 is -54. All right with that?
Yes, I think I had skip the order of operations. I think I had multiplied the two in parentheses by each other on accident.
And then right.
I think
right.
that's where I went wrong.
Okay. You betcha. You betcha. All right. What else? Other questions? Anybody? We good to go on to 5.5 then? I'll take that
Yes,
as a
sir.
yes. Okay. Here we go. And let's see. I don't know which thing is showing right now. So I'll just go back here and make sure that everybody can see my writing screen. Okay. So we've been talking about polynomials. What we're going to do now is we're going to add or subtract polynomials. Okay. Now, and I know that not all of you took Math 85 or Math 84, the beginning algebra course here at YVC, but if you did do that, in this same book, back in chapter 2, they talk about the idea of combining like terms. For instance, if you've got 3x plus 4x squared plus 5x minus 3x squared, the 3x and the 5x are like terms. We add their coefficients and get 8x. The 4x squared and the minus 3x squared are like terms. We add those and get 1x squared. So we get 8x plus x squared. And then if we went and wrote it in descending powers standard form, we'd write it like that. Okay? So the idea of like terms, if they have the same variable to the same power, they're like terms, or the same variables to the same powers. Okay? What we're going to be doing in this section of chapter 5 is adding or subtracting entire polynomials. So let's see here. For instance, and we'll get things a little more complicated as we go along. To start off with, let's say we've got 15x squared plus 10x squared. So you could argue that we're going to add two monomials together. They are like terms because they both have x squared in the variable. So we're going to add their coefficients. 15 of something plus 10 of the same thing is 25 of that something being x squared. All right, so 15x squared plus 10x squared equals 25x squared. Any questions about that? Okay. 17y squared minus 22y minus y squared. So here we have three terms. The first term and the last term are like terms, but they're different from the middle term. Even though they have the same variable, because they're different degrees, they're not alike. 17y squared minus 1y squared is 16y squared, and then minus 22y. And we can't put those together any further. They aren't like terms. Any questions about that?
So that's the solution?
Yep, that's as far as we can condense things.
Perfect, thank you.
Yeah, and we're not really solving anything here. We're just condensing, putting things together that are alike. Okay?
Makes sense, thank you.
Alrighty, good, because that's my story and I'm sticking to it. All right, let's say we've got negative 3y squared minus y minus 6y squared plus 7y. So the first and the third terms are alike, the second and the fourth terms are alike. Negative 3y squared minus 6 more y squared would be negative 9y squared. Negative y plus 7y would be plus 6y. Again, remember that negative y is negative 1y. So that's our final answer. Y squared and y, not like terms, can't put them together. We good to go with that? All
Yes.
right. Now things get a little bit worse, as they always tend to do. We've got 1/5 x squared minus 3/8 x plus 2/3 x squared plus 1/4 x. All right. Now, like terms have nothing to do with their coefficients. So even though these two terms have fraction coefficients with different denominators, they're still like terms because they both have x squared in the variable position. Same thing with the minus 3/8 x and the plus 1/4 x. Those are like terms. What I'm going to do, I'm going to rewrite this, putting the like terms next to each other. And you don't have to do this step. I just like to get things a little bit better organized sometimes. So I'm going to put these two like terms together. But to do that, I need a common denominator. What is the common denominator of 5 and 3?
15.
15. Okay. So now I'm going to take 1/5 and multiply it by 3/3 to get an equivalent fraction to 1/5, but one that has the denominator of 15. So 1/5 is equivalent to 3/15. Is everybody clear on what I just did there?
Yes.
All right. I need to take the 2/3 and change it to something over 15. So I'm going to multiply it by 5/5, which makes it 10/15. So 2/3 gets built up to 10/15. So now I've got 3/15 x squared plus 10/15 x squared. Okay? So that becomes 13/15 x squared. So we've combined the like terms that were x squared to 13/15 x squared. And I can't reduce 13/15. All right, we're halfway done. So now, let's take a look at this second part. What's the least common denominator of 8 and 4?
8.
Right. So that first term doesn't need to be changed because it already has the least common denominator. But this second term, I need to multiply by 2/2 so that 1/4 becomes 2/8. So the negative 3/8 x stayed. The 1/4 x became 2/8 x because we need a common denominator in order to add or subtract fractions. Any questions there? All right, so now I've got minus 3/8 plus 2h, which would be minus 1/8 x. So there is my final answer. 13/15 x squared minus 1/8 x. Any questions? All righty. Let's see here. Let's do one that is a decimal. We've got 1.9 m to the 4th power minus 2.4 m to the 6th power minus 3.7 m to the 4th power plus 2.8 m to the 6th power. Okay, these two terms are like terms, and those two terms are like terms. So I've got 1.9 m to the fourth minus 3.7 m to the fourth. Let's just focus on their coefficients. 1.9 minus 3.7. Now, if you're using a calculator, it's easy. You just go in and you go 1.9 minus 3.7, and you get negative 1.8. So you'd get negative 1.8 m to the fourth. But in case you're not using one and you want to remember how this works, let me take you through that, okay? First of all, let's say I had $1.90 in my checking account, and I wrote a check for $3.70. Can you see that you've overdrawn your account? Because you're taking away more than is there. So you know your answer's going to be negative, right?
Yes.
Okay. So subtracting a number is like adding its opposite. When you're adding two numbers with opposite signs, you subtract the smaller absolute value from the larger absolute value. And then you go back and attach the sign of the number that had the largest absolute value. And I'm guessing at this point you're going, oh man, I've got a calculator. I'm going to find it if I don't have it, and just use the calculator. But that's how you go through that process of getting the negative 1.8. All right. Second half of the problem. We've got minus 2.4 plus 2.8. Here again, on your calculator, if you went negative 2.4 plus 2.8, you come up with 0.4. So this is going to be 0.4 m to the sixth. Okay. Now, this is a correct answer, but I just want to talk again about something called standard form, which is descending powers, where you put the variable with the largest power and then the next largest, et cetera, et cetera. So they're both correct answers, but 0.4 m to the sixth minus 1.8 m to the fourth would be an even better answer, descending powers of m. All right? Any questions there? Okay. So let's take a look at this scenario. We have 2t squared plus 11t minus 15 plus the quantity negative 5t squared minus 13t plus 10. So I have a trinomial plus a trinomial. When there's nothing in front of a trinomial, like the first one, there's no plus sign or minus sign or a number or anything, it's basically like there's one of them. And we could get rid of the set of parentheses and just write it like that. Okay? Now, we're adding a second trinomial. When there's a plus sign, it's like plus 1 times that. If we distributed that plus 1 times that, we would basically get minus 5t squared minus 13t plus 10. So if there's nothing in front or a plus sign in front of a set of parentheses, basically you just bring out what's in the parentheses. Okay? Now that we've gotten rid of the parentheses, we can combine like terms. But we need to break down those parentheses before, we need to get rid of them before we combine like terms. So those go together. 2t squared minus 5t squared is negative 3t squared. And those go together. 11t minus 13t is minus 2t. And finally, those go together. Minus 15 plus 10 is minus 5. So there is the final answer. And it's, again, written in standard form, descending powers of t. Any questions about that problem? Okay.
Yeah, let's say I was to put a 3 in front of that first 2t to the second power 11t minus 15t, and you were to put a 2 outside of that parentheses, would that transfer to every number?
Okay, let me make sure I understand. So you're saying if there was a 3 here,
Sure.
and is that it? Everything else is the same?
Well, no, then you would distribute that
Well, no, but I mean, is
throughout
that, is that the only thing you want to change in the problem? It's just that.
correct.
Okay,
Correct.
let's take a look at that. Let's see, 11t minus 15. Yeah, so you'd get 6t squared plus 33t minus 45, and then whatever else, et cetera, et cetera. So yes, you would take that and you would distribute it to the parentheses.
Perfect. Thank you.
You're welcome. Okay, and we'll deal with that some more later. What do I want to do? I want to look at this, and let's go back to black instead of red. Let's say we've got 2x squared plus xy plus 3y squared plus the quantity 5x squared minus y squared. So again, nothing in front or a plus sign in front. I'm going to just rewrite this without the grouping symbols. Combining like terms, the x squareds go together, the y squareds go together, and the xy, there's no like terms with it. So I've got 2x squared plus 5x squared is 7x squared. Then I'm going to put plus xy, and then finally, 3y squared minus y squared is plus 2y squared. And again, this is in standard form in terms of x, because I've got x squared, x to the first power, no x's at all. Okay? All right. Now, we're going to add two polynomials in a vertical format instead of a horizontal format. 6x cubed minus 4x squared plus 7, 7x cubed plus 9x squared plus 12. And so we're adding these together, okay? 7 plus 12 is 19, so that's a plus 19. Negative 4x squared plus 9x squared is 5x squared, so that's a plus 5x squared. And 6x cubed plus 7x cubed is 13x cubed. And I don't need to put a plus sign in front of that because there, with nothing else there, it's assumed that it's positive. Okay with that? Okay, now let's take a look at subtraction. This is where things get a little more complicated. Let's say we've got 3a squared minus 2a plus 4 minus the quantity a squared minus 3a plus 7. There's nothing in front of the first trinomial, so we can just bring the trinomial outside of the grouping symbols. But we're subtracting the second trinomial, so we have to distribute that subtraction sign. And again, there's like an implied 1 in front of each of these. Well, in the first one, 1 times everything is just the everything. But in the second one, minus 1 times everything, we're going to have, and here we're going to distribute like you had me do earlier. We're going to have minus a squared. Minus 1 times minus 3 is plus 3a, because minus times minus or negative times negative is positive. And then minus 1 times 7 is a minus 7. Okay? So we distributed the negative or the minus 1 to that second group. Now everything's outside of the grouping symbols. We're going to combine like terms. Those go together, and those go together. 3a squared minus a squared. It looks like a 9, but it's really an a. 3a squared minus a squared is 2a squared. Minus 2a plus 3a is plus 1a, and plus 4 minus 7 is minus 3. So there is the resulting difference of those two trinomials. So with subtraction, you've got to distribute that subtraction, and it ends up changing the sign of everything inside the group. Okay. Let's see here. How about this one? It says, let's see, 3x squared plus 4x plus 5 minus 2x squared minus 2x plus 3. So again, the first group can just come right outside the parentheses because there's nothing in front. Distributing the subtraction sign, we get minus 2x squared. Minus times minus is plus 2x, and minus times plus is minus. Okay. Combining like terms, 3x squared minus 2x squared is 1x squared. 4x plus 2x is 6x, and 5 minus 3 is plus 2. So there's the result. Any questions on that problem? Okay. Let's see. Here's a rather long problem. Hopefully I can write small enough and get it all on the page. So we've got 2x squared minus 3x plus 1 minus the quantity 4x squared minus 3x plus 2 plus the quantity 2x squared plus 3x plus 2. So we've got 3 trinomials. We're subtracting the first 2 and then adding the third. Okay? So the first trinomial, there's nothing in front of it, so I can just bring it out and get the same thing that was inside. Okay? The second trinomial, I'm going to distribute the subtraction sign, so I'm going to get minus 4x squared. Minus times a minus is plus 3x, and minus times a plus is minus 2. The third trinomial is plus, so I'm going to get just what's inside because multiplying what's inside by a plus 1 doesn't change what's inside. Any questions so far? All right. Combining like terms, 2x squared minus 4x squared would be negative 2x squared, plus 2x squared is 0x squared. Now, I could write 0x squared, but I don't really need to in this context. I just won't write anything yet. Minus 3x plus 3x plus 3x. Minus 3x plus 3x is 0x. Plus 3x, oh, I've got 3x so far. And then 1 minus 2 plus 2 is just plus 1. So the result of that addition and subtraction is 3x plus 1. Any questions on that? Okay. Now, here's one that's a little bit trickier. We've got 7m to the 5th plus m cubed plus 9m squared minus m. And then down below we've got 8m to the 5th minus 2m cubed plus m squared plus m. Okay. But we're going to subtract that second polynomial from the first one. Okay. Now, let's go back to arithmetic days. And let's say you had 7 minus 10. subtracting a number is like adding its opposite. So this would be like 7 plus negative 10. Okay? Subtracting a number is like adding its opposite. So in this context that we're looking at here, distributing that subtraction sign is like changing it to addition of the opposite. And let's see what that does. Okay? So I'm going to change it to addition of the opposite. So that becomes negative, positive, negative, negative. Distributing the subtraction sign changed everything inside. But now it's an addition sign. So we can now get rid of those parentheses and just add up each column. I know this is a bit confusing. It's a lot to take on. You can do this. So I've got minus m is minus 2m. 9m squared minus 1m squared is plus 8m squared. Plus m cubed plus 2m cubed is plus 3m cubed. And 7m to the fifth plus negative 8m to the fifth is negative 1m to the fifth. So there's my final lovely answer. All righty, any questions on that? Okay, so we're going to wrap this up for the day, and I will go ahead and stop the recording.